And we're back for part 2. Okay, so we left off where we were doing the test points for this one. And test points, again, I was just saying, we just went over one, and we were talking about what the point of doing that is to try to figure out where this graph is. Okay, so we know for this one that this graph is going to go to where when the number gets really, really, really large. Okay, and this one's obviously a little more complicated than the first one we did. So if the graph gets really, really, really big, let's just test like one point to the right of the asymptote. So let's see, vertical asymptotes at -2. Let's check like, I don't know, 5 or something. Let's kind of see where we're at. So let's put in x equals 5 and see what we get. Nice crappy green. So put in a 5 for x, and what are we going to get for y? Okay, well, I'm going to put it into that factored form up top here. So if I put a 5 in there, I'm going to get a 3, okay? And down here, I'm going to get a 7. Of course, the x plus 1's cancel out. So that's a 3/7. So if I put a 5 in, I get a 3/7. Is that above or below my horizontal asymptote? Well, my horizontal asymptote is at 1, so that's below it. So 3/7. So if I put a 5 in, 2, 3, 4, 5, something like that, I'm going to get some number up here, okay? And so you know what that means is that this graph is going to follow that asymptote, and it's going to curve and come in like this. Well, not exactly, but kind of a rough sketch there. Right, so the test point is to figure out what the graph looks like and what it's doing on either side of the asymptote. Okay, if we put a number, of course, close to the asymptote, and there's an asymptote at -2. So if we put like a negative 1.99999999999 in here, right? If we put a negative 1.999999999 in for x, what would happen is we'd get a really small number for that. And so if you take a decent sized number, even a 1 divided by a really small number can be a really big, that would be a negative number, because in the top you're going to have a negative, that's negative 1.99. So it's going to, and that's why it's coming from down here at negative infinity. It's going to be a really big negative number. It's going to come all the way up. It's going to get closer and closer to 1, but it's never going to get there. Okay. What does it do on the left side of the asymptote? What if we put in like a -3? Okay, so if we tried like a 1, 2, 3, put in a -3, what do we get? Well, it's getting messy up here, but if I put a -3 in, the x plus 2, that's going to be a -1, right? And if I put a -3 in up here, that's going to be a -5. And the -5 divided by a -1 is a positive. So that's going to come up here, and this one's going to look like that. It's going to be like that. Because a negative divided by a negative is a positive, and so that's going to be positive up here somewhere. I don't know. Not a perfect sketch. Making sense? You guys can ask questions even though I'm recording. You don't have to be like, this is just hush hush, this is whatever. You good?
Yep.
Mm-hmm. Okay, one more example. This one's a little different. This one turns out to be a little different. We factor the denominator. We have x plus 3, x minus 1 over x minus 4. Okay, any holes in this one? Nah, no holes. Okay, any vertical asymptotes? Wait a minute, was there a hole in our last one? Yeah, it was at -1. Well, I should have made that on the graph, shouldn't I? I forgot about that. See? All right, there's going to be like a hole at -1 right there. Okay? Got it? Okay, any vertical asymptotes? Yep, one at -3 and one at 1. So x equals -3 and x equals 1. Okay, let's go ahead and draw those in. 1, 2, 3, 1. Just like in Caddyshack, right there. Okay. Any horizontal asymptotes? Well, the bottom is bigger by 1 degree than the top, so that means we're going to have a horizontal asymptote at y equals 0. So we have y equals 0 again as one of our horizontal asymptotes. Okay, any x-intercepts? This one does have an x-intercept because we have a factor in the numerator. So what makes the numerator 0 is going to be x equals 4. So 4, 0 is one of my x-intercepts. And the y-intercept for this one, if I put 0 in for x, what do I get out for y? Well, that's going to be a negative 4 times or over a 3 times a negative 1. So 3 times negative 1 is negative 3 over negative 4. That's going to be a positive 4/3. So 0 4/3 is a y-intercept. And so now let's do test points.
Excuse me for this announcement. This is for those off-season weightlifters. We're not able to have you go to the weight room today. Corey Callahan is ill, so he's not able to take care of you in the weight room today. So again, that's just for the off-season students that want to get their workout in. Our weightlifting team is still able to hold practice, and those student athletes that are in winter sports, you can still go to the weight room with your coaches.
All right, that's enough. We get the gist of that. So let's finish this up. Test points around these now. This is going to be a little weird. Let's test point x equals 2. Let's check it out when x equals 2 to the right of this. So what happens when I put a 2 in there? If I put a 2 in there up top, here I'll just put this like this. Up top, if I put a 2 in there, I'm going to get a negative, right? And a positive and a positive. So what's a negative divided by a positive? That's a negative, so it's going to come up here. Oh, also, I forgot to put this on the graph. 2, 3, 4. We're going to have a 0. So this is a little funky right here, but we have a 0 at 4, but we just put in a, what did we put in? We put in a 2? Yeah, we put in a 2, and we got out a negative. So if we put it, it's coming up from here, and it's actually going to go up through, and then it's going to come back down and trend towards 0. Okay, like that. What if we put a 0 in? What do we get? Well, we already did this, 4/3. So 0 4/3 is a thing. All right, but we know there are no more zeros. That was the only 0. So this isn't going to cross. It's going to do something like this in between there. That's a little wild, huh? Okay, and again, this is just a sketch, so don't freak out about getting everything perfect unless you wanted to like plot every single point in there and get something great. You don't have anything good to do with your time. All right, what happens to the left of like negative 3? Let's check like x equals negative 4. What if I put a negative 4 in there? Well, that's going to be a negative 8 up there, so a negative there. If I put a negative 4, this is going to be a negative, and this is going to be a negative. And so it's going to be a negative over a positive, which is also a negative. So this side here is going to go like that right there. It's kind of a funky little... You get these rational functions and you get these things going like that. And high five to me and the rest of us. We made it in the nick of time, even though TG's interruption about Corey being sick. Get well, Corey. And for the rest of you guys, have a great, nice, blustery winter day. Oh, no.